Hey guys, this is CHEMPLIFIED and today we will talk about aromatic compounds. In this video, we will not start with the definition of aromatic compounds. We will start with the question that what are aromatic compounds, right? Now, in various books, you will find different kinds of definitions, out of which I will read out one. Aromatic compounds are organic compounds also known as mono and polycyclic aromatic hydrocarbons. The parent member is benzene. This is one of the definitions of aromatic compounds, but there is no need to go for the definitions. We will go for the conditions which leads any molecule to be aromatic or not aromatic. We will talk about the conditions which tells us whether the compound is aromatic or non-aromatic. Let's start with the first condition. First of all, let's make the diagram of benzene, the parent aromatic compound, right? Now this is the structure of benzene, right? Now this is 100% aromatic, we know that. From this molecule aromatic compounds started. Now first condition that tells us whether a compound is aromatic or non-aromatic is the compound should be cyclic. The compound should be cyclic. Benzene is cyclic, yes. Second condition is planar. Planar means the compound should lie on the plane of paper. All the atoms present in any particular molecule should lie on the plane of paper. If, for example, CH4, in CH4 you will find that two hydrogens are on the plane of paper and the other two hydrogens are above and below the plane, right? So this molecule is not planar, this is three-dimensional. The geometry is three-dimensional, but if you look at benzene, the geometry is two-dimensional. All the atoms in this particular molecule lies on the plane of paper. How can you tell that? All the carbons are sp2 hybridized. The hybridization is sp2, and the geometry that it will form is trigonal planar. So trigonal planar simply leads to planar geometry, right? Third condition is conjugation. Is benzene conjugated? Yes, it is conjugated. Now let's take another example of conjugated molecule. Let's take another example of conjugated molecule. For example, this. Right? Is this in conjugation? Yes. So this condition is satisfied. Now the hybridization of all the carbons is sp2. So the geometry is definitely planar. Second condition is also satisfied. Now look at the first condition, cyclic. Is this molecule cyclic? No, this molecule is not cyclic. So this is not aromatic. These are the three conditions that you can follow and apply to any compound, and you can tell whether the compound is aromatic or not aromatic, right? Now there is another condition, fourth condition, not necessary, which is not necessary. Fourth condition is not necessary to apply. It is Huckel rule. Aromatic compounds follow 4n plus 2 pi electron rule, right? Where n is equal to 0, 1, 2, 3 and so on. What is 4n plus 2 pi electron rule? When you put n is equal to 1, you will find that it will come to 6. So benzene is also what? 6 pi electron molecule. There are 6 pi electrons. How many bonds are there? Pi bonds? 1, 2 and 3. And how many electrons are there in it? 6. So this is 6 pi electron system, and it is following Huckel rule, hence it is aromatic. So these are the 4 conditions that you can apply to any molecule to find whether the molecule is aromatic or non-aromatic. Fourth is supplementary. You want to apply it, you can apply it, otherwise there is no need. Upper 3 conditions will also tell you whether the compound is aromatic or non-aromatic. This is the structure of benzene. As you can see from the structure itself, that all the atoms are in one plane. If you make axis, this is x-axis, y-axis and z-axis is above and below the screen, right? So you will find that on x and y-axis you can make the whole molecule like this. There is no need of the z-axis, which means this molecule benzene is planar. And just like benzene, all the other aromatic compounds will be planar in nature. Even if you make 2 rings, and if this is also aromatic like this, then it is also planar in nature, right? That's how you have to see the compound. Now let's move to the next test for aromatic compounds. This is known as unsaturation test. Now there is something different between aromatic compounds. There is something different between aromatic compounds and non-aromatic compounds. What is it? We will look at that. When any aromatic compound is treated with bromine or KMnO4, it will not show any reaction. So there will be no reaction. Right? But when any other unsaturated compound like this cyclohexene is treated with bromine or KMnO4, it will decolorize bromine and KMnO4 because it will form compounds like this. This is dibromo. It will form dibromo compound, and with KMnO4 it will form diol, right? Now why the color of bromine and KMnO4 disappeared after the reaction? Because they reacted with the double bond and form a new compound. That's why decolorization occur. But in case of aromatic compounds, they will not react because of much more higher stability of these double bonds in the compound, and no reaction will take place. So the color of the bromine and KMnO4 will remain same. It will not decolorize. This is known as unsaturation test, and this test is used to tell whether the compound is aromatic or non-aromatic, right? Remember this. Now let's move to the next comparison of stability of aromatic compounds. Since we are talking about aromatic compounds only, we will focus on aromatic abilities. But just for remembering or just for learning, just try to remember it. This is the series or sequence of stability of aromatic compounds. Now aromatic compounds are most stable. If you are comparing some compounds and if there is an aromatic compound, then it will be most stable. After that, homoaromatic compounds will be stable. After that, non-aromatic compounds will be stable, and most unstable will be anti-aromatic. This is most unstable. Remember this sequence. Now what are aromatic compounds? We will try to take some examples to understand what kind of compounds come in which category. Aromatic compounds, we all know about the conditions, and we will take benzene, or you can also take furan, right? These are aromatic compounds. Now what are homoaromatic compounds? These kind of compounds are homoaromatic compounds. This is 6-membered ring, this is 5-membered ring, now this is 7-membered ring, right? Now look at the placement of double bonds. By looking, you can say that all these 6 carbon are in conjugation, right? All these 6 carbon are in conjugation except of this one. This is not in conjugation with the other. Now this is 4n plus 2. This is 6 pi electron, right? This is 6 pi electron system if you apply the Huckel rule, but it is not completely conjugated. These two, this one and this one, are not in conjugation. So what you will do is you will put a positive charge. Now you will find that this compound is in complete conjugation because this is electron deficient. The electron will transfer to this side. Now the positive charge will shift to this carbon. That's how it works. That's how conjugation works. So this compound is now aromatic, but since it is not same as these benzene, so we have given a new name, homoaromatic. All right. So these kind of compounds comes under the category homoaromatic. Now what are non-aromatic? Non-aromatic are just non-aromatic, which are not in conjugation. This is non-aromatic, right? Completely non-aromatic. This is diene, cyclohexadiene. Now anti-aromatic. What are anti-aromatic? Anti-aromatic are those compounds that follow 4n pi electron system. This is also in Huckel rule. We will talk about it in some other video, where n is equal to 0. If you put n is equal to 0, the answer will be 4. And how many pi electrons are there in this? This is cyclobutadiene. Cyclobutadiene, how many pi electrons are there? 4 pi electrons are there. This is anti-aromatic. So these are the example of different kinds of compounds. Focus on aromatic and this sequence. Remember this sequence. This is the stability sequence, right? Now these are the examples. Just tell which one is aromatic, which one is non-aromatic, or just focus on aromatic compounds. You can pause the video and then tell. Now first one is definitely aromatic, benzene. Second one is aromatic, right? Third one, now there is a lone pair of electron. There is a lone pair of electron which is parallel to the pi bonds, these two pi bonds. So conjugation will be there. So this is also aromatic. Now look at this one. This is 7-membered ring. These 6 carbon are in conjugation, but the upper one is not in conjugation. This is non-aromatic. Again look at this next example. We have done this. Since there is a positive charge, this is also aromatic, or you can say homoaromatic, right? Now this is anti-aromatic, we have discussed. Look at this one. How many electrons are there? Now this negative charge means there is electron. There are electrons in this orbital. Now if I make the structure once again and make the p orbital, and this is double bond, you will find that this p orbital has 2 electrons and it is in conjugation with this double bond, right? Now how many electrons are there? 4 electrons. This is 4 pi electron system. And what 4 pi electron system means? Anti-aromatic, right? This is non-aromatic. This is anti-aromatic. Why? Because there is a positive charge. How many electrons are there? This is 4 pi electron system. 4 pi electron system is anti-aromatic. We have discussed. Now instead of positive we put negative charge. So this will become aromatic, right? That's how you go according to the rules. In all the aromatic compounds, you will find that all these compounds are cyclic, planar, conjugated. These three conditions will definitely apply. You can use it on any compound and can tell whether the compound is aromatic or non-aromatic, right? This will be it for today's video. Thank you very much.